Hello everyone, so welcome to my channel, and today we will speak about the very interesting topic, more precisely, that is the light for dioramas. Something like that. It's a very complicated way, like how we can make the light harmonized with the sound there. So you can see here the low and the broken voltage sound combined with the flicking LEDs, and then of course we could control it. I can just switch off any sound. I can make the very bright light, so I can just switch it on, and generally I could combine it, and then I could generally change the sound modes. Like this one is for loud stuff. So, and generally all that possible due to connection of the LEDs and with some electronics Arduino. So that case is using Arduino Nano, and that's a pretty complicated setup made up here. And today we will see more specifically how I'm making such projects and how you could do it at home without any complexity, and how make it simple and easy. So, ready? Let's start then. So, and firstly, we will see what types of lights and diodes you can use in your project. That could be that one, that could be that stuff, even the teeny tiny diode or something like that. Let's see how they are working, what is needed to start. And actually, before making any specific project itself, that's much easier to test it just in advance. And for the testing, regularly I'm using that board, the testing board with the power model. Here you can find the link for that and description of that model and how actually that's working. I just plug inside the power model for that. Just the regular one, 20 volts, the power source. So, and here we have the switcher, and actually based on that switcher we can manage that position. Now it's 5 volts there, and this switcher is 3.3 volt there. So, and we could start using that. And how that board actually is working. Here we have the several parts. The first one, this upper one and the bottom one, is the power bus. And actually that all those holes are linked with each other, and that upper part is the plus and that one is the minus. Actually that's equal to the one what is indicated on the output of this power model. And similarly here, that's all plus and that's all minus. But based on the setup of our power device, the upper side is just 5 volts power, source power there, and here we have 3.3 volt there. So, and then actually all those holes are linked in such way, like the columns, like those are linked at the rows, and that one linked at the rows, like that. So here we have the same signal. And then if we proceed with one or another LED device, so we are always could use them, that power. So this is the first type. Actually, this is the flicking diode. what already soldered together with some resistance here, and actually that's needed completely nothing to set it up. And actually what we are doing, we are inserting the red cable to the plus, the black cable to the minus, switched on, and see it's lit, and you can use it in your dioramas. So that's even more. This is the kind of a flicking mode. I can switch off the light now. It's flicking. So pretty cool to use anywhere. Then the second type would be the regular diode, like that. So how to use them? Actually, diodes are very sensitive to the power, and actually for my diorama regular I'm using the 5 volts power, because that power is required to Arduino Nano, the chipset I'm using as a brain for everything there. So this is why the main power source in my all dioramas, in all my power sources are 5 volts. So, and that guy will burn immediately if you put the direct 5 volt power on it. And for that purpose, we need to use the resistor there. And actually you can buy them at the set of the different resistors. You can find the different types of them. Here the 470, 47, then 300, and there are really many of them, and they are super different. So, and for our purpose, I used 220. I think this is the very regular one what we could start from, and that would be the brightest power. So thus, as more resistance you're adding to your diode, then less bright that will be. So how that's working? Actually, resistor is not sensitive for the side, for the polarity. So thus you are putting that on the plus in one side, just like that, and in any other place for the other side, like that. So you plug it inside. Then you remember that those lines are linked. So basically what we have here, we have also there. And we are just putting inside the diode. How to understand what side should be put it to minus and which side should be put it to the plus. Thus, diode is the sensitive. So actually you can just put it inside, and if it's not lighting, you just turn it around. But that could be dangerous for some cases. The easiest way is to find the shortest leg. Here you see the one is little bit longer, another one is shorter. This one is shorter, and actually we will use that one for the minus. The plus leg we are putting just after the resistor, like here, and the minus we are putting to the minus. So, and thus our circle, you can see it's lighting already. It goes the plus 5 volt there, then it goes to resistor 220, then this, it's still plus, goes to our long leg there, and then to our power, to our diode, and then it goes to the minus. So, and it is lighting like that. Actually pretty same as the previous one, but without any flicking mode. There are a lot of different colors and the types of diodes you can use for your projects, something like that. And actually you're just choosing whatever that's interesting to you, like that. Again, see 2 legs, one short, one long one, and we're using the long one here, short one here, bam. So it's lighting. Quite bright, deep blue color. So then you can use the red one. Let's check the red. Completely same approach. Something like that. So, good. This is how those diodes working. Then also you can find another type of diode there, is that teeny tiny diodes with the different colors. So that's almost, I don't know, like the biggest size is around 1 millimeter. So, and fortunately this is already pre-wired. And here we're using completely same approach. We are putting the minus, the black cable into the minus, and the plus after the resistance to the plus. And then we are switching it in, and you can see that teeny tiny light is here, but pretty bright, I would say. That is cool. So then what I'm using further is the LED strips. Actually, for the LED strips, you can use the alternative power source. For that case, is the battery holder for CR2032, like that, 2032, and this is 3 volts, you see. So it's 3 volts only, and actually those diodes, most of them are working on the 3 volts also. And in that case, you can just switch it on, and that's working like that. Honestly, I love those strips. Good. Then, if you wanna change the power, how bright is that? Let's go to that diode one more time. So long one here and the short one here. So it's lighting like that. Actually, you could use the other resistor, and as more you're taking, as less bright that's going to be. And let's find something. Okay, here. 470 as an example. Actually, yes, better be here, just not to lose it. That's 220, I think that's my most common resistor I'm using for my projects, so better not to lose it. And again, I'm using the plus on the one leg, up, like this, and you can see that it's significantly less bright. Probably it's not such visible on the camera, but trust me, it's less bright. And then you can go up to, I don't know, 100 kilo ohms, where you can see completely nothing, or 1 kilo ohm or something less bright. So, and this is actually the simplest methods, where you can you need actually nothing. And then we have the more interesting and more smart ways. And here we have that smart LED, Actually, here you can find on the screen that's name, and that diode actually, or the LED lamp, requires already 3 wires. Actually, that would be the very similar and the very regular 5 volts and the ground there, and plus it requires some controlling cable. And to control it, that would be needed some Arduino Nano in our case. So, and how is that working? Actually, we will use Arduino Nano for our needs, and actually we will use the power from the Arduino itself. So we will use the 5 volt. Here are the names of the different, the channels of the Arduino, the different pins. And here you can see that this one is ground, what is needed for us. This is another ground. Then this is a 5 volts, and the other channels are just for different options. And for our LED, we will use D6. Don't ask me why this is what I did the software for that. Actually, even not me, but AI, but that helped. Oh, so I connecting at the moment. I will not wire that, as it's just for the testing mode. So I connecting D6, the controlling cable, then 5 volt for the power, the plus from there, and then I'm using the black cable, this one, for the ground. And actually we could use the same power as from here. We are just using the 5 plus. We will put it here, from here to here, and minus we will take from the minus to here. But the easiest way how to make and how to settle that, thus you need the software uploaded, that would be your laptop. And now I'm opening my Mac, and I will need a cable. That one is USB Type-C, that Arduino Nano is USB Type-C, and then just plug it in, and I will use the power of my USB to lit it. So at the moment nothing is opened, I'm just using the source, the power of it. So, and you can see it's lit like this, pretty bright. Then you can actually ask why this one is better or more smart than another one. Actually, because here we have the different colors, the different diodes integrated in that LED, and you could control them by the Arduino. So, and to control it, actually you can make that by the software. You can tell them that now it should be yellow or green or blue, whatever, all those colors like that, it would be integrated there. But at the same time, you could control it like an interactive way. And that's a various way how you can, how you could put inside the command, but regularly I'm using the buttons. So this one is button, what we will use for control. And actually how button is working. Actually that's super simple. Here we have 2 legs, linked, not linked, but 2 legs generally. And those 2 legs are the same. Now that's visible. All right. So this is the same signal. So they are linked and those two are not. But when you're pressing button, so that two will be linked, and that would be signal going from here to here. And how to find are they linked or not? Generally, you can use the multimeter. I'm using mine. Power is off for some reason because my laptop is switched off for some times, and then we are using that function of like the finding the connection. If we have a signal, that would be the beeper. If not, then not. And actually, if we are just touch the two legs, you see those two, that would be the beep. That means that this signal and this signal, they are similar, like I showed you. And here the same. Another one, another couple. So, and then we have no signal between that and that. I mean, between the green and the black one. But if you press the button, like now, that would be a signal. So this is only thing what this button is doing is just linking the one leg with another one. And how we could use that? So actually we will use again our Arduino, and we will use the black one. This is the one side of button that doesn't matter which side, should be always ground. You're always linking the signal with ground. And I just putting inside to that ground I used for my LED. So the ground I use for the LED. I'm using the same point for the grounding of my button. And if you would use the power source like the external one, like that, so you will use the ground from your power source to here. So that would be the easiest way. And then I'm using to find the signal. For the signal, I did the software that it would be the D2 pin. And let's connect it to the D2. Something like that. At the moment, I'm not using any soldering. That's just for the demo. And actually, now we are just setting up our setup, just to check if that's working or not, to choose whatever would be used in the real work. All right. Be careful where you put that inside. It should be the right one. All right, the ground. So, and actually, nowadays, at that time, we have completely same setup as the previously, like this. But now we could control it. And actually, how you could control it is depending the software you make it. And at that moment, what I did, I just modified the warm of the light. Each press is just making the light warmer and warmer. Until they're off. And that would be proceeding. To press, that would be the very different colors you can use. At the moment I did it at the rainbow, but actually that could be good to use any purpose you need. now that's again not leading because of not the best stability of my setup. So, but still, long press, that's off. Another long press, that would be switched on, and so on. Actually, that's unlimited abilities how you're supposed to use it. So that's a super cool. So, and actually that would be the first part, how I'm making the setup, then I'm updating the software, and of course I will put the software file to the comment there. And then here could be a question how to make the powering of that entire system. That's of course, or actually that could be that you're okay to power that through the USB Type-C, that is okay, but in the most cases you want to have the remote powering, and we will speak about that right now. All right, let's proceed with the second part, powering of our system. Actually, power is really important. Let's make our system a little bit more robust. So power is really important. Thus, it depends on the power, how robust will be your system, and for how long that will survive. So, and actually, that's worth to take care a bit, at least a little bit, to confirm that your power is okay. So, and actually, how we will start with it. I hope that's good enough. We need a power source. In our case, we could use the batteries mostly. So we can use that 3-volt power. That would be the option A. Then the two main types of the batteries I'm using, that would be that 14015 type of a battery. That looks like the AA type of a battery, but see that the 3.7 volts and 500 ampere hour. So, and this is a pretty nice size. And then another type, that would be this 18650. So that also looks like a battery, but it's much bigger. It's again 3.7 volts, and this is 3200 milliampere hours. So actually this is like 6 times even more powerful than more capacity, and the duration of that usage would be 3 times longer than this guy, but this size, and this is even smaller. If you have the little diodes, the very like that, so that would be enough for, I don't know, half hour or sort of that, even probably less. If you have the Arduino and all the rest stuff, I don't know, that would be the minutes. I even really don't know for how long that would be. If you have that guy, so that would be even with the other stuff, like the other sensor or the MP3 player or sort of that would be around half hour and 1 hour. This example, this project is powered by that battery, and the duration of life of the entire project of the max power would be around 40 minutes. So, and that give you the hours. And the biggest problem with all of that stuff is the voltage. Actually, this is 3.7 volts, and you already know that's for all our lights, and actually for Arduino and for that stuff, the voltage is really crucial. So, and we need the 5 volts actually to power up, that's all. And actually what we could use to power our system, we will use the boosters. Here the two main boosters I'm using for most of my project. This is very convenient, and here you can find this name of this of that stuff. And actually it's super nice that you could adjust the voltage just depending on how much you need it. So this is the one, and actually it's holding up to 1 ampere or a little bit more, it depends on, and actually that would be enough for like the dozen of the LEDs plus MP3 player plus Arduino plus something else. So that's pretty okay. But if you want to have something like that, dozen of the LEDs plus Arduino plus fog generator plus fan with the reductor plus you would have some servo which opening something like up and down and so on. So for that probably 1 ampere would be not enough, and you need something bigger. And this is one is another type what I'm using there. It's much more powerful, and actually that's taken whatever it's from there and it's modified for the 5 volts, and you just take the result. But again, we are paying by the size and cost, of course. Here you can see how much bigger that. So in practice, how that looks like in a simple way. Actually, we are using the battery holder. We are using our battery. Put them inside. That's done. And then we are connecting the minus to minus, plus to plus. That's fortunately pretty easy and logical. Actually, it's already some power inside, and we are using that little block, and we see here that it's V in and V in minus, V in plus, and out minus and out plus, and we just connect the V in minus to minus, alright. Plus you should solder everything, and now I'm not using soldering just for the demo purpose. So we are using like that. Again, let's fix it. Hop. Good. And then we could measure what the voltage is outside. I'm using my multimeter. Plus, minus, and you can see it's 9.5 volt there. And then we are taking the screwdriver and we just adjusting the voltage. Super conveniently. Okay, that's 8, 7, 3. Six, 5 and 2. Can even hold it a little bit up, something like that. So we have the 5 volts out of there. Good. We got it. So, and then just don't touch it, and that would work. So, and what next? I also prepared 2 wiring there. just to connect the power, but I load them. Of course, that's, as you can see, it's not super perfect order there. Nevertheless, here are those two wires, and then we are taking out from here, and we are putting out to our Arduino there, and we are using plus, out plus, and again we are linking them to the plus. Let's a little bit rearrange our setup. Like that. All right, and then out plus, we will give to the plus, and minus, we will give to the minus. And see, that's lighting. Completely same result as we had from the USB, but now that's fully battery powered. Okay, I will not proceeding with that setup. It's already super unstable. What else you can do actually? You can use the same stuff, but instead of that you can use that guy, which is the bigger one. Actually, how is that working? Also very simple. You're just finding the V in. This is a voltage in. The cable 1, ground, put the cable 2. That's easy. Let's check. Ground. Stop. Okay. Just to switch stuff. A voltage DC. Okay, 5 volts there. Completely same setup. Show no screw anything, and actually you can use the same minus. The plus you're giving to our 5 volts, and the minus to ground. And actually here again our diode is lighting. Good. So this is how you can power the system. What else? I would recommend you to have any switcher. Actually, how that's supposed to be. Now, before even switcher, you should have an ability to charge your battery. Thus, That's really cool stuff. And for the charging, we are using that block. So actually, instead of this booster, you connect your battery to the connectors like the B minus and B plus. So, and then out, you're giving to that booster. So that looks like from battery to charger port. And then from the charger, you are going to the booster, and that's super cool to be able just to switch off. And actually, you can use that switcher. That's super small, super convenient to use. And actually, what this guy is doing, he's just connecting that pin with the one of the sides pin to the central pin, and you're just connecting your plus cable to that to the central pin, and then to the one or another you're just wearing your another side like your battery. So you're going from battery to one of the side pin, then from the central pin you're going to the booster. And when this handle on the side where the pin is located, so it's going, the current is going there. If it's on the other side with the empty pin, that is not going. And actually that's simple as that. It's just linking those two. If it's linked, it goes further. Not, then not. You can use also the more fancy way, something like this switcher, the rocker switcher. That's completely same function as the main switcher, where this one. So that is cool. Then you can use fuse. So, and there are the different types, something like that. And actually you can put it somewhere in between your battery on the plus, just on the battery to the charger or whatever you wanted. And this is the type of the fuse where the current is exceeding some limit. You can use AI to find out what kind of fuse you need. It's just displug the plus and everything kind of is safe. All your system, your Arduino, your LEDs, everything is safe. Otherwise, that could burn your device. This costs like the peanuts. That one could be pretty expensive, and plus the time you spend for that could be even more remarkable. So easy and cheap, you could use it. So and then this is the self-healing fuse. So then after some time, that's again start being the conductor. So, and you can work with that further. That's generally, that is it. And lastly, I would say that I would discuss the other controls, how you could control all that setup, like with the making that light. Actually, the button is the simplest and the easiest one. Let's try to lead it. Oh, we have another ground here with it. Yeah, good. So we can use, of course, that button, and that would work. This is the first option. Meanwhile, now this entire system is working like from that battery. So another option what you could use, that would be that potentiometer, or how it's called, rotation sensor. Actually, you again connected like the ground, VCC, you are connecting to your power, and the out you're connecting to one or another pin of your Arduino, completely same as the button actually. And how that helping you, that actually you can just turn it and that's this is the resistor inside, and you can change the brightness based on that, or you can modify it based on that it would be the different setups, the same way as I'm pressing button there, like to change the temperature of the light. You can use the same sensor like here. Then you can use the distance sensor. This is kind of wave measuring device, and it's measure the distance, and that's pretty same approach. You just connect it to your Arduino, and then it's measured that if something happened, if it show that something appears like your palm there, it's sending the signal to the Arduino, and then you're programming that one or another stuff should happen. You can use some other distance measuring methods like that. Actually, this is the pretty same, but the laser method. So, and just a different method. This is kind of a laser measuring the distance. This is the using the ultrasound. So then you could use the sound. Actually, this is the sound, and here we have the adjustable gain even. So, and actually you can also connect that guy to the Arduino and also tell it that please, if that would be the sound very quiet and very little noise, use the option A, or if it's the high sound, the high level gain, so you can use the another one, or just if there any sound, please lead your diode. And actually the smart home, the device is working pretty same approach. And the last sensor generally I could share to you, that would be this vibro sensor. Again, you could find there quite easily how to connect it to your Arduino, and here in that box something rattle there, and actually that's sensitive. When you're just touching it even nearby this sensor, there's probably little balls or something inside giving the some command to the device that something happened, and then it's sending the signal to Arduino that actually that's some vibration, like you touch the diorama or touch the sensor near that. So, and you could use that for any of your scenarios. So that's pretty cool. And this is how that's working. Probably the last stuff what I would mention, but I will not go deeply today, would be the powerful light devices. Like in that one, in that guy, I'm using really powerful diodes. They are even the LEDs, and actually you can see that here we have even 8 of the LEDs, and pretty powerful. They are total power around 800 milliampere. So, and the currency of the Arduino will not be enough to power that, and actually you can burn your Arduino. And for that purpose you are using the MOSFET. That could be looks like that, or that could looks like that. So, and actually this is the way how that was used here. Actually how that working in the principal level, this is kind of just a gate, and you're giving the plus to your power source, to your LED, and minus goes through that guy from one leg, and another leg goes to the leg, the minus from the battery, or directly from the battery, even not from Arduino, but from the battery goes to that, to one leg, and another leg goes to your power source. and then signal for the last leg goes from Arduino. And actually Arduino telling that when signal will be sent here, that please open the gate. So, and the currency is going there. How Arduino could tell, that could be again the button, that could be one or another sensor, any of them. So, and actually if that event happened, that's sending the signal that the LED should be switched on, and so on. And then another press that please close the gate. It's depending on how you will program your Arduino. And actually those MOSFETs should be the logic level. This just the code the logic level does. It should be able to be opened and closed based on the voltage which is Arduino is able to give it there. So, and that logic level for Arduino would be the 5 volts. And this is the purely MOSFET, how that looks like. And this is the MOSFET wired together with some LED indicating either opened or closed, with some resistors, and with the terminals just to connect your LED or some other device through the screws instead of just wirings. So, but that's more complicated, but always use those for the anything more powerful that than regular diodes, like those big and powerful, or for the fork, or for the actuators, for the for basically any demanding power sources. So that's it for today. Thank you for watching. Let's be in touch, and thank you. Bye bye.